Okay, now, so what's going to happen here is that you can see that the reaction between sodium and the halogen to form your metal halide is a vigorous reaction. So the first chemical properties is we know that halogens will react with metals to form halides. Okay, so just take note, halides are actually your salts. Now, second thing is that we know that halogens, they are powerful oxidizing agents. Okay, now, why are they powerful oxidizing agents? It's because they will actually gain one additional electrons to form a noble gas structure. So all my halogens, they will gain electrons. When they gain the electrons, they will become a negative ion. So they actually, it undergoes reduction. Okay, the halogens undergo reduction and oxidizes other things. Okay, it oxidizes other substances. Okay, substances. So just take note of this. So the first property you talk about, it reacts with metals to form halides. Second property we talk about is that it is a powerful oxidizing agent. Last one, we're going to talk about this new term called a displacement reaction. Okay, it's actually very simple. Just think of it as such. Okay, think of the metal, maybe sodium, being a man with a halide. So this is a woman. Imagine they are a couple. Okay, now this halogen here, okay, is actually more reactive. More reactive means sexier. So imagine a man and a woman who are together is a couple, but when the man sees a sexier woman, what will he do? Okay, I'm not teaching you some wrong values here, but normally, you know, in the movies, this is what you'll see. When a man sees a sexier woman, what will he do? He will go for the sexier woman and he will kick away his current woman. Bad stuff. But then, this is how your halogens react, man. Come on. So, you can see now your sodium is with the chlorine now. Chlorine is your sexier woman. Then your bromine is now left alone. Why? Because bromine is not as sexy as your halogen. I talk about sexy here, sexy. It means equals to reactive. The sexier you are, the more reactive you are. So the more reactive halogens will actually displace a less reactive halogen from its halide solution. So the halide solution is like the couple. The solo, the halogen, which is not reacted to anything, is the single woman. So the man, which is the metal, will always go for the sexier woman. So in this case here, we can see from the reaction that chlorine, which is the more reactive halogen, it will displace bromine, okay, from the sodium bromide solution. So chlorine, who is the sexier halogen, has displaced bromine, which is a less sexy halogen, from the couple. Okay, so it kicks off bromine out from as a couple. So now you can look at this reaction, it has taken place. So using the same analogy, you realize what is happening. Bromine is the more reactive halogen. And definitely iodide is the not so reactive halogen. And that is why bromine has displaced iodine to form a couple with potassium, okay, or to form a compound with potassium. And iodine now is left alone. So which is more reactive? Bromine is more reactive because it has displaced iodine from the potassium bromide solution. Okay, the more reactive element, okay, take note, the more reactive element will displace the more reactive halogens will displace the less reactive halogen. Okay, so just take note of this. Now, in actual fact, when you look at the displacement reaction, they're actually redox reaction. If you simplify it, okay, realize, oh, it looks like this. Okay, rather than looking at the gaining and the loss of electrons, you can think of chlorine. Because its element on its own, the oxidation state is 0. Br here, negatively charged, so as oxidation state, Br, oxidation state, -1, follow the charge. Chlorine here, oxidation state, -1. Bromine here, element on its own, oxidation state, 0. So as you can see, from -1 oxidation state to +1, this is an increase, okay, in oxidation state of +1. Then for this case here, for chlorine, okay, this is actually a decrease in oxidation state of -1. Okay, OS stands for oxidation state. So in actual fact, your displacement reactions are actually also your redox reactions. Now this is quite a big chunk to digest. Okay, we're nearing the end of our halogens, so just stick to this. Stick to it. Okay, now let's look at the next reaction here. We got our halogen here and a halide solution, and it says here no displacement. Why is it no displacement? Why is there no displacement? Why no? Why no? It's because we know that bromine is less reactive than chlorine. It cannot, okay, I say again, it cannot displace chlorine. Okay, so obviously we say a more reactive halogen can displace a less reactive halogen. The other way around doesn't hold true. Okay, it means that the less reactive halogen cannot displace a more reactive halogen. Okay, cannot. Please take note. Cannot displace. Less reactive cannot displace a more reactive halogen. This is one thing you must always remember. Okay, so now with that in mind, you realize that, okay, what's the trend? The trend lies in, as it goes down the group, okay, the reactivity decreases, the oxidizing power decreases. Why? Okay, remember, for your halogens, they want to gain electrons. Okay, halogens want to gain electrons. Now, you can see fluorine is generally small in size, followed by chlorine slightly bigger, bromine even bigger, iodine even bigger, and astatine is the biggest. Now, to attract electrons, what is actually the thing that's attracting it? Is the thing in the middle here, your nucleus. Your nucleus is the one that's attracting the electrons. So as you can see, if my electrons are somewhere around here, do you realize that the distance between the electrons and nucleus is getting further and further? Because as the size of the atom increases, okay, size of atom increases, it becomes more difficult for the nucleus. Okay, it is more difficult for the nucleus to draw an additional electrons into a valence shell. Or rather than saying draw, you can say attract. Okay, it's really about attraction here. Okay, attracting the electron into its valence shell. So this is the trend here. The reactivity decrease, the oxidizing power decrease. You must know the reason why. This is regards to the size. Right, size. So this marks the end for halogen. So we covered the physical property, we covered the chemical property, we talked about the trend. One new thing that we learned here was also known as the displacement reaction. Okay, displacement reaction, which we went into some details about it. Okay, using the couple analogy. So this marks the end for halogen. We're going to go into the last part, which is your noble gas.